for letting me borrow her money for a year, and then at the end she'd have 105 bucks. Now with the modern advent of technology, they don't do it that way anymore. What they do is they compound your money usually continuously. Sometimes they don't do it continuously. We'll talk about that too. And there are a couple of different ways to look at your money when you do that. So one is continuously and one's not continuously. If you're not doing something continuously, then you're going to use this formula. So that's not continuous. If you are continuous, then you're going to use this formula. I call it the PERT formula because it looks like PERT, P-E to the R-T. And in this page, in this slide, you will see that they talk about what each of the different letters mean. For example, A is the amount that you get out of your account after so much time. P is the principal. That means how much money you invested. R is the annual interest rate. And N is the number of pay periods per year. A quarterly. That means if I say that was 12. Daily. 5 on a non-leap year, and so forth. So let's try a few problems here and see what happens when we check these. So down below it says, I'm going to invest some money. I'm going to invest $5,000. What does the $5,000 represent? P. It's in an account that pays 6% annual interest, which represents R. And I'm going to go for 10 years, which represents T. And what I'm going to do is, I'm not going to do all of these for you, but let's talk about, for example, B. So let's do letter B here. Quarterly. If I want to find the amount of money quarterly, what I would do is, wait a minute, is this continuous or not?
Yes.
No, because it says quarterly. That means 4 times. Continuous means you can't tell me how many times it goes on forever. Infinite number of times. So I'm going to use the orange formula. Or in other words, the amount that I'm going to get out of my account is going to be the amount that I invested, which was $5,000, times 1 plus 0.06, which was my interest, divided by the number of times I'm compounding this money. It was quarterly, so I'm compounding it 4 times, raised to the number of times I compound it times the amount of time. So I compounded it 4 times, and it was for 10 years. And what you're going to do is you're going to type this into your calculator. So I want you to type that in your calculator, see if you can get the same thing I get, because we should have the same answer, right? And I get 9070.09. Make sure you can get that. If you didn't get that, that means you probably forgot a parentheses around the exponent. So give that a shot, and then we're going to do one more.
He likes it. Yeah, I know it's on like TBS.
Let's try letter D, which rhymes with D. So if I'm looking at compounding my money daily, which in today's day and age, you should easily be able to get out of a bank because they have computers. I'm still going to take that amount that I wanted, that $5,000 that I want to invest. I still have the formula 1 plus the interest rate, which is 0.06. But this time, I'm compounding it.
Never did.
Can I get a number? Can I get a number?
365. A billion.
365. Why? Because that's the highlighted thing up there. Not a billion, not continuously. Exactly 365 times, because they tell you. And then you take that 365 and you multiply it by 10. And strangely enough, when you get this number out, you see that it's $9,110.14 to the nearest penny, I believe. Please check that out. And what I want you to notice is, look at the quarterly to the 365 days. There's a $40 jump. Well, maybe that doesn't mean a lot to you. Because maybe you only got $100 in there and not 5,000. So it's gonna be a lot less than $40 actually. But imagine you're Bill Gates with $50 billion. That's a huge difference. So the more times you can compound your money, the better off you are. And the best situation, and the situation that banks probably should be doing for you right now, is they should be compounding your money continuously. Let's see what happens when we do that. That's the other equation, the PERT equation, the one that looks like this. And what that means is I'm going to take my invested amount of money, 5,000, times e to the rate, which is 0.06, times 10. Check that out and see what you get. Hopefully, whoa, psychedelic, baby. What are we doing? Whoever asked that question is going to get poked in the eye with the scissors.
A broken scissors, so you probably get tetanus.
Unless you've had your tetanus shot. You should get $9,110.59. Notice how there's only really a 45-cent difference instead of a $40 difference. So it's not as big of a difference. But again, if you were Bill Gates, this is a lot of money. Okay. So in this problem, you didn't actually have to graph anything. You just really got to do this. 32,000 e to the 0.0367 times 28. Why? Because we're going from the year 1980 to 2008. That's 28 years later. So when you write this out, you will find out that to the nearest human being, you should get 89,000, I believe, 419.
Oh.
A few bits and pieces.
I was thinking money.
Record this actually, so it's online. So the important thing to know is that when you see this t equals 0 is 1980, then when you're looking for another jump to 2008, that's 28 years later. And that's why when we look at this, we see the 28 in here because we're talking about the 28 years later.
But couldn't you put it into the y equals and then...
So one of the things that happens is in our world, you might have been hearing about like nuclear deterrence in the past and stuff like that, weapons of mass destruction. In this class, we do something similar. We have weapons of math instruction. You guys, that's on the video. Come on, seriously. Let me get a wave. Wave, Gannon, start out the wave. Let's go. All right, you bunch of dung. All right. Half-life. Half-life means how much time does it take before half of my material is gone? So, A, we're going to look at and see how much material is in the beginning when the time is 0 in A. That means that I have 10 times 1/2 to the 0 over 5,730. What's 0 divided by 5,730?
0.
That's right, 0. What's 1/2 to the 0?
0.
1. 10 times 1 is
10.
10. It's good that our basic math skills are good. That means we're starting with 10 grams. Again, it's not a drug reference. B. In B, you want to find out what happens after 2,000 years. So, we go 10, 1/2 to the 2,000 divided by 5,730 to see what that equals. And I get roughly, I think, 7.85 grams. Check that out. Make sure I got that right. half. And then in part C, we're supposed to sketch this between 0 and how many years? 10,000? So if we sketch this out, this is in thousands of years. And then over on the side, we know that we start out with 10, this would be in grams on the side. And you can grab your calculator and take a look. And what you would see if you were to plot along is you could start out at, this is again for part C that we're doing. You start out at 10 grams, and then we're going to plot some points. Bless you. And what you'll notice, and this is not an exact curve, but what you'll see is that after 10,000 years, you have maybe about a quarter of your stuff left over. So it looks something like this. And oh my goodness, it looks like a...
log. No.
Exponential. Thank you, Gannon. It looks like an exponential graph. Now, if you actually wanted to go and see what was going on, you could, in y1, put your equation, and then you could do the Ask Auto thing, and look at 1,000 years, 2,000 years, 3,000 years. Again, that's referring to the fact that we have our equation that we would be putting into y1. Wherever you see the t, that would be an x for your variable. And you can check that out. But they want you to understand that this thing looks like an exponential graph.